Hello and good morning. My name is Krishna Joshi and welcome to Easy Learning with Krishna. So today we are going to learn structure of an atom, NCERT textbook chemistry chapter, grade 9. So the concepts we will learn in this session are what is an atom and structure of an atom, constitute of atom, what is a canal ray, Thomson's model of atom, Rutherford's model of atom, Bohr's model of atom, electronic configuration, atomic number, and atomic mass number, and isotopes and isobars. So let's get started. What is an atom? So what is structure of atom? The smallest particle in a chemical element that can exist is an atom. Structure of an atom consists of protons, neutrons, and electrons. Number of protons and electrons are equal in an atom, so the atom is electrically neutral. And atom structure is proposed by many scientists like Thomson, Rutherford, and Bohr. So, who discovered protons? What are canal rays? So, who discovered protons? Protons are positively charged particles in an atom. So, who discovered it? It is Goldstein discovered protons, positively charged particles of an atom. And then, what is canal ray? Yeah, wait, yeah. So, this is canal tube, cathode ray. Canal tube. See, canal rays are positively charged particles discovered by Goldstein in a gas discharge tube at high voltage and low pressure. There will be high voltage here and pressure inside this tube is low. This is cathode ray. Next. So next concept is Thomson's model of an atom. So Thomson compared an atom with that of a Christmas pudding. He thought an atom looks like a Christmas pudding. See, this is negatively charged particles or electrons, and there is positive sphere. So what Thomson proposed is that an atom consists of a positively charged sphere, and electrons are embedded in it, like this. You can see, and then the next thing he is proposed is the negative and positive charge are equal in magnitude, so atom as a whole is electrically neutral. Okay, if you have any doubts you can comment me down, and if you haven't subscribed my channel, so please subscribe it. Then next is Rutherford's experiment. Before proposing the model of an atom, Rutherford proposed an experiment. So what was it? It was like he selected a gold foil because he wanted as a thin layer as possible, because gold is the most malleable, so it can become very thin. Then this gold foil was about 1,000 atoms thick. He specifically took it as 1,000 atoms thick. Then he passed alpha particles through it. Alpha particles are doubly charged helium ions, or positively charged. Then, since they have mass of 4 units, helium particles have 4 units as helium atom have 4 units as the uh, mass. Okay, so the fast moving alpha particle have a considerable amount of energy, because it's where the mass is very less, so it can move very fast. It was expected that the particles would be deflected by the subatomic particles. So the atomic particles inside this, he thought that it will be deflected by subatomic particles in the gold atom. Since the alpha particles were much heavier than the protons, he did not expect to see large deflection. He thought that most of them won't pass through. This experiment is known as alpha particle scattering experiment. So what happened is he radiation source radium. Okay, so here he put that helium particles and then he passed it very large speed, and then most of them passed it through. That's because electrons attract positively charged the particles. Electrons are negative and it attract positive, so this passed. Then here there might be uh, atom. So no, sorry, here there might be nucleus of that atom. So you can see it deflected some of the particles like this and like this. And if this particle, alpha particle, hit that nucleus at the center, nucleus is positively charged, you can say, and neutral, right? So if it hit that center, then many of them even deflected like this, see, like this, and some of them rebounded like that. So this was the experiment, and this is fluorescent sheet, so he can observe it nicely. Next is Rutherford's model of atom. So what he proposed as a model of atom is that atom has positively charged nucleus. Nucleus is positively charged at its center, and most of the mass of atom is in the nucleus. As the electrons are light, he thought that most of the mass is in nucleus. Then second point is the electrons revolve around the nucleus in a different orbits. Electrons revolve around in a different orbit. See, this is the atom, so he thinks that electrons revolve around this in different orbits. Here is one, then another orbit, here is one, like that. Then the third thing he proposed is size of nucleus is very small compared to the size of an atom. So this whole is an atom, nucleus is only this much. So you can say that if your atom is, for example, okay, if your atom is as big as a football field, then your nucleus will be as small as a football. There is one fact that is there was a defect in Rutherford's model of atom. There was one defect. It was that he was unable to explain that if electrons revolve around the nucleus, then why isn't the atom getting burst off, or it's not? Why isn't there? Why is it existing? because uh, because if charged particles revolve, then it will be accelerating, and if it's accelerating, then it will lose its charge and gradually crash into the nucleus, and the atom won't exist, right? So that's what he wasn't able to explain. Next is Bohr's model of an atom. So he says that an atom consists of a positively charged nucleus, and the electrons revolve around it in a special, see, there is a word, special orbits, called discrete orbits or energy levels. If you want to write these things, you can pause the video and write it, because these things are very important, it might come in your exams. So a special orbit called discrete orbits or energy levels. So here it explains that the electrons revolve in a discrete orbit or special orbit, like here, like that. So it won't crash into the nucleus. Then second point he said is the energy of these orbits remain fixed. So the energy here is fixed. Then the energy here is fixed. So it won't change. So even if the electrons accelerate, this won't change. Then the third point he told is these energy levels are represented by 1, 2, 3, 4 or K, L, M, N. So this first is K, then this is L, M, and the last one is N. This is what you're going to learn in 9th grade only. In 11th grade, it will be different. Subatomic things will come and all. So you don't need to worry about it right now. Or you can even say 1, 2, 3, and 4. It's like, then electronic configuration, most important part. Okay, you need to learn this very well and practice it. Then you will understand. See, KLMN is known as electronic configuration. Sorry, then so you can fill each cell by the formula 2n square, where n is the number of cells. So when they ask you the electronic configuration of an atom, so first you need to know the number that you learn next slide. So this is the formula with which you have to fill it. So arrangement, yeah, this is what is the arrangement of electrons according to the shell. So the first shell or K shell 2n square is equal to 2 into 1 square is equal to 2 electrons. So the first shell, right? So 1 square. Then 2 multiplied by 1 square is 2 only, because 1 square is 1 and my 2 is 2. So 2 electrons. It can, first shell can hold 2 electrons. Then second shell. Here there's a mistake. Okay. Just neglect. The second shell or the L shell. Second 2n square. The formula remains the same. 2 into 2 square. So 2 square is 4 and 4 multiplied by 2 is 8. So say L shell or second shell can hold 8 electrons. Then the third shell or M shell, the formula is the same, 2n square equals to 2 into 3 square. So because this is the third orbit, so it is 3 square. What's 3 square? 9. So 9 multiplied by 2 is 18. So it can hold 18 electrons. Then the last cell, N cell, or the fourth cell, the formula is 2n square is equal to 2 multiplied by 4 square. So what's 4 square? 16. 16 twos are 32. See, 32 electrons. But there is one fact, it's that even though the calculation says that M and N shell can hold 18 electrons, 18 and 32 shell electrons respectively, it's not possible practically. It's not possible practically. That you will learn why isn't it? Not in this grade, but when you go further. So practically they can hold only 8 electrons, both of them. So here is 2 electrons per shell, K shell can hold. Then here it's 8, 8 and 8. So total 26 electrons only. See, next. Example of electronic configuration. See, I'll show you some example. So example 1, if the atomic number is 8. So the atomic number is 8, then what you'll do? See, the K shell will be having 2 electrons. So let's draw 2 electrons here. 1 electron and 2. So this is 2. I told that K shell cannot hold more than 2 electrons. We saw it, right? Then next is L shell can hold 6. So 6 plus 2 is 8 total, right? So 6, but as L shell can hold 8 electrons, but we are here it's 6 only, because 6 plus 2 is 8 and the total atomic number is 8 only. So 1, 2, 3, 4, 5 and 6. Yeah. So if you are representing the electronic configuration, then this is how you will represent, and you will write it as K equal to 2 comma L equals to 6 or 2 comma 6. That both of them are correct. And if they ask you for representation, this is how you will represent it. Yeah, then second is atomic number is 11. So what will be in K shell? 2, because it can hold only 2. So K has 2, 1 and 2. Then it's 11, right? Then L will be having 8. So 2 plus 8 is 10 total. So here L is having full. L is full. 1, 2, 3, 4, 5, 6, 7, 8. You should draw this properly, because I am not able to draw it very nicely. So 8 cells. So how many are total? 10. And there's one more, right? See, it's 11, right? Yeah, 11. K L M. Wait, what is this? 17? Okay, if yeah, there's a mistake. If this is 17, okay, consider this 7. So 17, right? So this is the electronic configuration for 17. So this is 10, then 11, 12, 13, 14, 15, 16 and 17. what's the electronic configuration? K equals to 2, L equals to 8, and M equals to 7. You can write like this, or you can write 2 comma 8 comma 7. See, this is how you can write, or and representation will be like this. You can represent it easily. You know that K shell holds 2, L shell holds 8, M shell holds 8, and K, L, M, N holds 8. So you can arrange it accordingly. You don't need to learn about it. The main thing you need to know is electronic configuration. Now it's easy, right? So the third example is if the atomic number is 10. So if the atomic number is 10, then it's simple, right? See, 1, 2, that's 2, and then L shell can hold 8. So finish, 10. 2 plus 8 is 10. 1, 2, 3, 4, 5, 6, 7, and 8. See, done. Very easy, right? So if you want to practice these things, then you can pause the video and do this again, and you can check it if it's 8 and all. You can even check the total if my total is wrong. So check it. Then the last example which I gave is if the atomic number is 20. You might think it's large. It's not. See, 20 means K shell holds 2, L shell holds 8, M shell holds 8, and N holds 2. So let's draw it here. K2, 1, 2. See, 2, this is done. Representation, okay? For this it's done. Then L8 full. 1, 2, 3, 4, 5, 6, 7, and 8. Full. And then M is also full, right? Because number is 20. So 2 plus 8 is 10, 10 plus 8 is 18, and 2 more. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, sorry, it's 10. Is it 10? No, right? So here it will be 8 only. See, you should observe. See how many are there right now? 1, 2, 3, 4, 5, 6, 7, and 8. See, 8 right now. You should observe like this. You shouldn't make like this mistake. Okay, that's why I showed you. So 8, 8, 16, and 2, 18, and 2 more. The last cell have 2. So if the last cell is having 2, then it will lose both of them. You'll get it to know in valency part. Next is valency. See, what is valency? So number of electrons lost, gained, or shared by an atom to become octet or acquire noble gas configuration. So noble gas configuration is that when an atom becomes fully full, the last cell is full, and so it won't be much reactive. And then if the outermost shell has more than 4 electrons, it will gain electrons because it can hold 8, right? So 4, then 5, 6, and 7, 8. So it can more than 4, so it will be 5, right? So 5, then 6, 7, 8. If it have then it can gain 3. 3 it can gain and become noble gas configuration. Okay, I'm not telling it will become noble gas. It will get the noble gas configuration. And if it has more than 4, less than 4, then if it is having less than 4, then see, it will be having 3. So it can lose 3 because we know that it can gain or lose 3. Most is 3. If the outermost shell has less than 4 electrons, it will lose electrons and the charge will be plus. So when it's losing, the charge will be positive. When it's gaining, the charge will be negative. That's because See, for example, I told you, right, 10 protons and 10 electrons, because both of them are equal in magnitude by the postulates of the people who proposed this atomic model. So 10 and 10, so equal. Now if it's gaining, then electrons will become more, right? So see, it's written, if the electrons, if it's gaining, right, then electrons will become more. So the atom will become negatively charged. So the sign is negative. And if the atom is losing electrons, then the protons will be the same number, right? So it will lose. So the atom will become positively charged. Or you can even remember it in the way that if it's losing the electrons, then it will be positively charged, and if it's gaining the electron, it will be negative. Opposite. Questions on valency now. Now, first question is that potassium. Potassium sign is K. You need to know this mass. You need to know mass. Mass of the atom is still 20 atomic number. You need to know the mass of their mass. Then you need to know their atomic number and chemical symbol. And configuration, now you know how to do it, so that's easy. So the potassium atomic number is 19. 19 is the atomic number. Electronic configuration, what will it be? 2 plus 8 is 10, 10 plus 8 is 18, plus 1 19, so 19. Valency is 1, so valency will be 1 because it have one electron only here. Here in the last cell it only have one electron, so valency will be 1. And the charge will be of course positive because it's going to lose it. Yes. The second example is neon. So neon has atomic number 10. So the electronic configuration is 2, 8. Valency is 0 and charge is 0. Since it's noble gas, the valency and the charge is 0, 0. Then scientific notation. See, scientific notation also you will see in your reference books and all. If you have, you will find it. Scientific notation. Mass number. What is mass number? See, mass number is round off figure of the atomic mass or the sum of the number of protons and neutrons. Then atomic number. The atomic number is number of protons present in an atom. Scientific notation. See, A stands for mass of the mass number. So if the element have 5 protons and 6 neutrons. See, the sum is of protons and neutrons, right? So what will it be? 11. So the atomic mass number will be 11. This is just an example, okay? You don't take it in reality. Then chemical symbol is represented by X. You will find that if the if the element X has the mass this and this, then find number of neutrons and all. And the atomic number is represented by Z. So let's find number of protons, neutrons and electrons. So oxygen first. Here you will write oxygen. Then atomic number of oxygen is given here 8. So you write it 8. Then atomic mass here is 15, but mass number you need to write. You don't need to write exact. So mass number is 16. 16 you don't forget you, okay. Then number of protons. How do you find number of protons? It's the same as the number chemical number or atomic number, okay. See, 8. Number of neutrons, in oxygen it's 8 because see, how to find number of neutrons is atomic number minus no atomic mass minus atomic number. So 16 minus 8 is 8. So here you will write 8. And number of electrons is 8 because it's equal to protons. Then for zinc, for the symbol Zn, okay, you write the atomic number for this is 30. Atomic mass number is 65 here, it's written. And number of protons is 30, it's given there, right here. Then number of neutrons is 65 minus 30 is 35, and number of electrons, you see, it's 30 because it's equal to protons here. Simple enough. Then lithium. This you can try out these problems. You can try out. I'll do these three. Then you can know it here how to do. Then lithium. So you write here lithium, and then atomic number. Atomic number here is given 3. So you write that 3 here. Atomic mass number is 6.9. So you will round it off to 7. So you will write it as 7U. Don't forget U. Okay. And then number of protons is 3 only. It's given. Neutrons is 7 minus 3, 4. Then electrons is equal to protons, 7 and 3 only. See, this one you can try it out as homework or practice work or anything. You can try it out. Yes. See the isotopes. So what are isotopes? Isotopes are same element having same atomic number but different atom mass number. Okay. So it have same atomic number but different mass number. And the examples I gave is hydrogen has 3 isotopes. See, one is protium, second is deuterium, and third is tritium. So atomic mass number is 1, 2, and 3. Chemical symbol remains the same, and the mm, number is 1, 1, and 1. That's number of protons. So they have same chemical properties. So let's see why. Why do isotopes have same chemical properties? That's because chemical reaction, only electrons participate in chemical reaction, and number of electrons does not change in isotopes. So number of electron doesn't change, only number of protons change. That's why they have different mass numbers. Last topic is isobars. Wait, it's last topic? Yes. Last topic is isobars. Isobars are atoms of different elements having different atomic number but same mass number. See here they have the same mass number now and different atomic number. So the example for this is calcium and argon are all isobars. So calcium mass is mass number is 40, argon mass number is 40, but uh, the atomic number is 20 and 18. See? So you can see that same atomic number but different atom, same atomic mass number but different atomic number. So those are isotopes. So example is calcium and argon. So this is the end of our session. Thank you. Hope you have understood, and if you like my video then please share, subscribe and like it, and if you have any questions comment it down. I'll try to solve it. Thank you.